Hey guys, welcome back. Wanted to come at you with another video here. This is my solar generator that I built using off-the-shelf parts from Harbor Freight, and just kind of wanted to do a quicker or a deeper dive into the setup. Wanted to go over the goals that I had when going into this project, share some ideas that I would like to do later on to kind of upgrade this and make it a little bit more efficient. So just starting off real quick, one of my main goals in this was to, of course, have a power option for when I am tent camping at either a campsite that doesn't have electricity, or I'm farther away from a vehicle where I can charge up some devices. So the main devices that I am looking to either use or charge when we're tent camping currently is a couple air mattresses that have 120 volt air pumps to air up the air mattresses. And for the most part, I have maybe 2 or 3 phones for the family, a couple tablets, and then also needing just to charge up my camera gear. My goal in all this is to have a device with off-the-shelf parts that I was able to put together relatively quickly, not have a ton of knowledge and skill in things like soldering or anything like that, just something to do very basic clips, to have this up within a relatively short amount of time. Also, again, having off-the-shelf parts means that I know that if I have a component of this system go wrong or have an issue, that I can easily just go to Harbor Freight or something similar, buy a new component, and replace it within this system to be up and going again. So starting on the line here, this is just a basic tactical ammo box. This is plastic, nothing special about it. It does have a nice top compartment here that I was using to store some cables in that I was going to be using later on, and then it opens up and reveals the inside here. It does have along the edges here a rubber seal. It does have a weatherproof seal here. Within the box, this is plastic, and relatively thin plastic. I wasn't able to find anything really thick to put like a screw or anything. So one solution that I found was just to use Velcro, like command strips. You can get the cheap type, like what I did. But this allowed me to very quickly put the components in, and I didn't have to have them in any certain place. So I was able to make adjustments, but this does allow things to kind of hold relatively well, and I was able to move things around to make it fit the way I wanted it. So the other component here is a 25 watt solar panel. This is a Thunderbolt solar from Harbor Freight. This has a kickstand on the back, so it is pretty easily positionable. Has about a 10-foot long cable, so you can get the panel to where the sun is, and still have your actual box within a decent area so that it's not too far away from you. So the next device here is the solar charge controller. Again, this is the Thunderbolt Magnum Solar. This is a 7 amp 100 watt max charge controller. This is something you have to pay attention to depending on what type of solar panel you're going to get, and what kind of battery you're going to get. So just a quick overview for this. This is a 100 watt max charge controller. That solar panel is a 25 watt. So you can do 4 of these solar panels in series, which would get you to the 100 watt max. That would be all that you can do before you potentially do damage to this particular charge controller, and you would need to upgrade. So this has 3 connections here at the bottom. One here for the connection to your batteries, one here for a connection to the solar panel, and one connection here for just your 12 volt load. This guy here is, if you weren't using a battery, you'd be able to wire in your 12 volt load center directly here from the solar panel and be able to power something. This has 3 indicators across the top here: high voltage, charging and low voltage. This doesn't have any other output from that. It doesn't tell you how much charge is going to the battery. It's just very basic, if it is or isn't charging, or if there's a high or low voltage, and it'll give you those warnings here. So from your solar charge controller, you would have your battery, and this is of course what stores the energy that you generate and is able to be used at a later time. This particular guy is a Thunderbolt Magnum Solar 12 volt 35 amp hour battery, again from Harbor Freight off the shelf. So this is where the connection would be made from the battery terminal here to the post terminals on the battery itself. So again, going with simplicity, so these are all Anderson connections coming off of the charge controller here. This makes just for a very quick and tight connection between either the solar panel and the battery. So we're going to go ahead and hook up the battery here. So this cable actually comes with the solar charge controller. This is just basically alligator clips. Again, we're going with simplicity. So we're going to make our connection to our battery, and then this simply connects to our battery Anderson connection. So it is night at this point. We do not have sun, but this is where once your battery is connected, you want to make sure your battery is connected first to your solar charge controller so that you do not potentially cause any damage to the charge controller. So once you have that plugged in, you would then plug in your solar panel. So what you should see once you have your battery connected and your solar panel connected is the center light here will light up saying charging. If you do not have that lit up, most likely you need to make sure that your battery is connected and has a good connection to the positive and negative, and that it is connected the right way. Black negative, red positive. And then that your connections are tight on going to both your battery and your solar panel. It of course is not lit up for us because it is dark out, so no sun, no charging. So from there we have our Jupiter modified sine wave inverter. This is a 400 watt max inverter. It peaks out at a 600 to 700 watt, but I have noticed that it doesn't quite get that. I've gotten up to 400, a little under 400 watts, and that's pretty safe and it'll run, but anything past that it tends to shut down. So from here, these cables actually come with the inverter itself, so nothing extra you have to buy. These have its own ring terminal posts here, so you can connect that, and then you would connect your alligator clips just like you connected your charge controller up. Again, going positive to negative. Oop. Makes me jump every time. So now we have our inverter connected alligator clips to the posts. We can now turn the switch on. We have our display that is now lit up. We see that the battery is sitting at about 12.3 volts. This will change depending on what load you are putting on the inverter, so this is not super accurate when the inverter is in use. And just to show that everything is connected properly, so again we have our solar panel that is connected to our solar charge controller, which is not charging right now because it is nighttime. Then we have our charge controller going to our battery, from our battery on another alligator clips coming over to the inverter. We have our powered up inverter. So now we can take something like a fan. You can see or hear that it is running. We can go ahead and maybe plug in another light. And you can see that this has actually dropped down quite a bit. We can completely turn off that inverter so that you can tell that both these are actually powering from the inverter itself. There we go. Alright. So now that we got everything connected up, we have tested, we know that our inverter is working, we know we're connected to the battery because of that correctly. Unfortunately, I can't fully show that I've tested the solar panel. You will kind of have to trust me there because it has been in use. But the solar panel is connected to the solar charge controller, which is connected to the battery as well. So this is where I was trying to make sure everything fit in the box itself. And I'll go ahead and start setting everything in there. So I started actually with the battery first because it is the biggest component and the heaviest component. I also put it towards the edge of the box here that has the hinge, because I wanted to make sure that the beefier part of this box was going to bear the most weight of this. Let's set this guy in here. So the bottom of the battery does have the command strips, which keep it from scooting around for the most part. It's not going to keep anything. If this thing tumbles, of course, it's probably going to come apart. But it does not scoot back and forth, so I don't have to worry about the cables moving around as much. So our start charge controller here, it's also on just the command strips. I'm actually going to set that aside and put the inverter in first. Goodness. So I did the same thing here. Velcro, command strips. That's just going to allow it to kind of sit in here. I had to play around with this a little bit because you don't want this right against the bottom of the box, because there are fans on the back side of this, and you don't want that to get overheated when this is in use. So this provides a little bit of breathing room. So just because we do have limited space in here, I am actually going to go ahead and take my connection between the charge controller and the battery, and I'm going to go ahead and make this connection, and then run this wire around this piece of cardboard. And the cardboard's there more to help keep the battery from moving around too much. So battery connection is the one on the left for this. So I'm going to make my connection here, run this cable around the back, and just stick it to the Velcro. So this is where it's a little bit tight in here, but I can see the readout for if it's charging. I can get to the connection for the solar, and there is still room for air to get around the inverter itself. So there's the connection for the solar. And then for the inverter, I just kind of tucked that down and put my alligator clip connections, woo, right there. Okay. Plug everything back in, just make sure it's all working. And there we go. So very quick and simple. So now this is able to close. This cable still does hang out. I hope at some point I'm going to either cut this out a little bit and maybe put a piece of rubber so this cable is able to hang out and not and still hold a watertight connection. But even with the way this guy is oriented, if you do have anything plugged into it, into the 12 volt or into the, if you have anything plugged into the 12 volt or the 120, it's still gonna hold this up a little bit. It's something later on I'll probably try to find a different way of moving things around to see if there's a better option. But again, this has been less than 5 minutes, not having to unbox everything, and we do have something that is fully operational. So some of the things I know I can improve is, instead of using alligator clips here, using ring terminals and connecting directly to the posts themselves. This is something that would allow you to not have the arcing every time you move something around, because if you do move this guy around, which you are, this is portable, it's supposed to be moved around, these terminals can potentially come loose and can potentially arc while you're moving things around. I will actually disconnect these fully when I go to move them, or if I'm traveling in a vehicle, I'll go ahead and just take these completely loose, tuck them to the side so that I don't have to worry about anything coming loose or shorting out and causing a problem. One of the other upgrades I would like to do is both get a lithium iron phosphate batteries. They're more expensive, but they are going to be lighter, and they definitely have a lot more capacity. So something that is supposed to be mobile, the lead acid is pretty heavy and hard to move around. The lithium polymer would make it a lot nicer to move around. The additional capacity is also very needed in this setup. This is a 35 amp hour battery, but however, this is a lead acid battery, meaning only about 50% of that is usable without potentially causing damage to this battery. So it's something you definitely have to be aware of as you're using this, to not let this discharge down too low. And again, I'll be honest, the setup does not have a reliable readout of the battery. That's something that I would need to get so that I have a better idea of what the battery state is at. Either one that would provide a better status of the battery and provide an actual breakout display that might be able to be mounted. But with getting a lithium battery, you would also need to get a different charge controller anyways, so that you have something that is made specifically to charge a lithium battery, where this one would not charge as efficiently. The inverter itself is also a modified sine wave inverter. So these are cheaper inverters, but depending on what you need, they really can do a lot. Just as long as you're not expecting to plug anything like your refrigerator or something that has a little bit more sensitive electronics in it, the modified sine wave will do damage to sensitive electronics. If you ever do plan to hook up a refrigerator, something that has that type of motor that is more sensitive to frequency, your pure sine wave inverters are going to be what you want because they provide cleaner power that is basically the same power that comes out of your wall from your grid. This guy for so far has done everything that I need. It has inline fuses for the 12-volt rail coming from the battery, so that's handy. I did not have to do any extra wiring to have an inline fuse. It's all here, so I don't have to worry about plugging anything into the 12-volt and potentially causing a surge. Same thing, the 120-volt already has built-in overload protection from the inverter. I don't have to worry about fuses or breakers or anything with this setup. Everything has been alligator clips and Anderson connections. So I hope I provided a little bit more in-depth look at this guy. Again, this is not the most efficient. It may not even be the most cost efficient. However, this has been a very good learning curve for me. Did find out, obviously, that I can take off-the-shelf parts. I can use very basic connections and have something that will work very well in the situation so far that I've needed it. Being camping, I do know that, if even at home I were to just need some additional lighting, if the power's out, and just some really emergency power, this can operate for a certain amount of time and is something that is completely usable. Thank you so much for watching. Please leave a comment if you liked it. If you have any questions, just please leave them. I will do what I can. I am not the smartest guy. There are definitely other channels that have done far more interesting things than this. But I will say that I am not the smartest guy, and I was able to find everything I needed at Harbor Freight, clip it together, plug it together, and was ready to go camping, and was able to utilize this very well. So, thank you for watching. Talk to you later.